So for this coding challenge, we are given an array of integers and we need to sort them in place, and we'll be using Quicksort algorithm. So when it comes to Quicksort, it's all about pivots, right? And like there's a number of ways we can choose pivots, but for this example, so we could choose the first number, the last, or the random number. So in this case, we will choose the first integers as our pivot, and all we need to do is just move pivot to the correct position, right? So in this example, if we do this, so 3, 2, we can see that 3 is sorted, right? So 3 is in the correct position, right? And that's because all the numbers on the left side are smaller than 3, and all the numbers on the right side are bigger than 3, right? And with Quicksort algorithm, we do this recursively, so on the left side and on the right side. And when we're finished, the array is sorted, basically. So let's talk about time space complexity for this one. So for time, the worst case is O of n squared. It's all about choosing the pivot, but on the average side is still O of n log n, right? So n is number of elements inside an array, right? So for space, it's linear, right? It's O of n, like so. Cool. So let's see how this would look in code. So if we have integers 2, 1, 3, 4, 5, or 5, 4. If we sort this array and print an array like this, we should get sorted array back, right? So let's first implement this sort function. Def sort, we pass it array and call Quicksort function. We will have low pointer, which points to 0, so the first index, and high pointer, which points to the last index, which is length array minus 1, like this. We need to implement Quicksort function. Quicksort, and we have array, low, and high pointers. Now this Quicksort function is a recursive function, and whenever we have a recursive function, we need to first take care of base case. In our case, when low passes or it's equal to high, we don't need to do anything, we can just return. If not, we need to get pivot, which we do with the helper function. We will name it partition, and we'll pass it low and high pointers. Once we're done, we just recursively call Quicksort again, right? Quicksort, and we pass it. So low can be, it's low, and until pivot minus 1, right? The next one will do pivot plus 1 until high pointer. And the last thing we need to do is implement this helper partition function. So let's do that. Cool. First we'll choose our pivot, which is low. So let's have pivot value, which is low. We'll also duplicate L and high pointers, which will change like this. And then while L is less than high, we can go into while loop, and inside this while loop we will be moving our pointers. So while left pointer is less than or equal to pivot value, we can move L pointer by 1, while high is bigger than pivot value, we can move H pointer to the left, like so. And if L is still less than H, we can swap L and H, like so. Once we're done, we need to move our pivot, which is so low, high. So we're moving the value from the high to the low, which is fine. And now we need to move pivot, which is h equals to pivot value, this, and we return pivot index, which is h, like this. Cool. Last thing, we need to implement the swap function. So a, I, and j. Like this. And if we run the function, oh, just reloaded the window, so that's fine. If we run the function, we get this index out of range. So this is line 9. Let's check this out. So yeah, here we can make a change. So if L is still smaller than H, and this fixes the error. So just to be safe, let's just insert a few numbers. So let's insert 6, 7, and 8. Okay, like so. And it's array sorted, so that's awesome. Cool. So to recap, so we have a sort function which just calls quicksort with the low index being the first points to the first index, and the high pointer points to the last index inside an array. We then go into quicksort function, which will just get the pivot and recursively call quicksort on the left side, and then recursively call on the right side. And that's basically it. Our partition function just puts our pivot to the correct spot, and that's it, right? So yeah, that's about it.